Question number 8, we need to check the convergence of the series summation 3n plus 2 by n into n plus 1. Now this can be written as 3n plus 2 by n into n plus 1. So this can be put in the form a by n plus b by n plus 1 by partial fraction. So equating the numerators, we will get 3n plus 2 equal to a n plus 1 plus bn. So if we equate the coefficients, we will get, so coefficient of n will be 3 equal to a plus b. Now constant will be 2 equal to a. So we will get a equal to 2 and b will be 3 minus 2, which is equal to 1. So therefore summation n equal to 1 to infinity 3n plus 2 by n into n plus 1 will be equal to summation n equal to 1 to infinity 2 by n plus 1 by n plus 1. Now f of x will be 2 by x plus 1 by x plus 1. So this will be positive. And as x increases, the function value is decreasing, so it will be decreasing, and the points of discontinuity are 0 and minus 1, so that is not in x greater than or equal to 1 portion. So this will be continuous, positive, decreasing and continuous for x greater than or equal to 1. So we will evaluate integral 1 to infinity 2 by x plus 1 by x plus 1 dx. So the integral will be, so integral of 2 by x will be 2 log x plus log x plus 1 from 1 to infinity. So at infinity the value is infinity. So therefore the integral is infinite. So by integral test the series diverges in this case. So that will be the solution. Question number 9, we need to check the convergence or divergence of summation n equal to 1 to infinity log n by n cube. Now if we take f of x will be log x by x cube, and it will be so if when x is equal to 1 the value will be 0, so it will be positive when x is greater than or equal to 2. So at 1 it will be 0, so from 2 onwards it will be positive. So it will be positive, and it will be continuous in this portion, so it will be continuous. And for the decreasing part, so if we take f dash of x will be, so the derivative of this will be x raised to 6, then x cube into derivative of log x will be 1 by x minus log x into derivative of x cube will be 3x square. So that will be x square minus 3x square log x by x raised to 6. So we will get 1 minus 3 log x by x raised to 4. So we can see that this will be, so f dash of x will be negative if 1 minus 3 log x is negative, so that is 1 must be less than 3 log x. So we will get log x greater than 1 by 3. So taking exponential on both sides, so we must have x greater than e power 1 by 3. So e power 1 by 3 will be 1.395. So all the three conditions are satisfied when x is greater than or equal to 2. So we need to evaluate integral 2 to infinity log x by x cube dx. So let us use a substitution, u equal to log x. So du will be 1 by x dx, and from the substitution we will have u is equal to log x, so x will be equal to e raised to u, and u will vary from So here x varies from 2 to infinity, so u will vary from log 2 to log infinity, goes to infinity. So this will be log 2 to infinity. Now log x will be u, and 1 by x dx will be du, and we have an x square remaining in the denominator, so that will be replaced by e raised to 2u. So we will get integral log 2 to infinity u e raised to minus 2u du. Now using integration by parts, this will be first function into integral of the second will be e raised to minus 2u by minus 2 from log 2 to infinity minus integral log 2 to infinity. Derivative of the first will be 1 into integral of the second will be e raised to minus 2u by minus 2 du. And at infinity we have e power minus infinity, that will be 0, and at log 2 we will get log 2 by minus 2 e raised to minus 2 log 2, then plus 1 by 2. Again integral of this will be e raised to minus 2u by minus 2 from log 2 to infinity. So this will be equal to, so we'll get log 2 by 2 and e raised to so we can take minus 2 as the exponent, so e power log 2 raised to minus 2, so we will be getting 2 raised to minus 2, and in the next term we'll get minus 1 by 4, and again e power minus infinity will be 0, so we'll have 0 minus e power minus 2 log 2, so that will be log 2 by 2 2 raised to minus 2 plus 1 by 4 e raised to minus 2 log 2. So this value is going to be finite, so therefore the series converges by integral test. Next one we have summation n equal to 1 to infinity 1 by n square minus 4n plus 5. So 1 by n square minus 4n plus 5 will be equal to 1 by n minus 5 into n plus 1. So this will be equal to a by n minus 5 plus b by n plus 1. So we will have 1 equal to a into n plus 1 plus b into n minus 5. So if n equal to 5, we will get a equal to, so we will get 1 equal to 6 times a, so a is going to be 1 by 6, and if n is minus 1, we will get, so this quantity will be 0, we will get 1 equal to minus 6b, so b is going to be minus 1 by 6. So the series will become summation n equal to 1 to infinity 1 by so this will be equal to 1 by 6, so this is equal to 1 by 6 by n minus 5 minus 1 by 6 by n plus 1, and if we take the denominator, so this will be equal to 1 by n minus 5 into n plus 1. So till the point of discontinuities are 5 and minus 1. So whenever n is greater than or equal to 6, and this quantity will be positive whenever n is greater than 5. So when n is greater than or equal to 6, it will be positive, continuous, and if we take f of x, so we have f of x equal to 1 by 6 by n x minus 5 minus 1 by 6 by x plus 1. So f of x will be positive and continuous for x greater than or equal to 6. Now if we take f dash of x will be minus 1 by 6 by x minus 5 whole square plus 1 by 6 by x plus 1 whole square, and here the denominator will be the lowest for this one compared to this. So this quantity will be less than 0. So this quantity is going to be negative. So this has a lower value of denominator. So this will be the larger number compared to this. So f dash is less than 0. So therefore the function is positive continuous and decreasing whenever x is greater than or equal to 6. So we need to evaluate the integral from 6 to infinity. So integral 6 to infinity, f of x dx will be integral 6 to infinity 1 by 6 by, so we'll have x minus 5 minus 1 by 6 by x plus 1 dx. So that will be equal to 1 by 6 log x minus 5 minus 1 by 6 log x plus 1 from 6 to infinity. So this will be 1 by 6. Now we can write this as log a by b form. So we'll get log x minus 5 by x plus 1 from 6 to infinity. So this will be 1 by 6. Now at infinity, so this can be written as log 1 minus, so taking x common from numerator and denominator, we can write this as 1 minus 5 by x by 1 plus 1 by x from 6 to infinity. So we'll get 1 by 6. So when we evaluate at infinity, 1 by infinity is 0. So 5 by 6 and 1 by x becomes 0. So we'll have log 1 at infinity. And at 6, we'll be having, so let us, now this is same as this term. So at 6, we have log 6 minus 5 by 6 plus 1. So 6 minus 5 is 1. So 1 by 7 will come. So log 1 is 0, we'll get minus 1 by 6 log 1 by 7. So this is finite, so it is less than infinity. So therefore by integral test the series converges. Next one, we need to check the convergence of summation n equal to 2 to infinity 1 by n log n whole square. So we'll have f of x equal to 1 by x log x whole square. So when x is equal to 1 on denominator, log 1 will be 0. So x cannot be equal to 1. So x must be greater than or equal to 2. So when x is greater than or equal to 2, so function is positive. And as x increases, the f value decreases. So function is decreasing, and the points of discontinuity are not there when x is greater than or equal to 2. So it will be continuous, positive and decreasing for x greater than or equal to 2. So we'll evaluate integral 2 to infinity 1 by x log x whole square dx. So for this we'll use a substitution u equal to log x. So du will be 1 by x dx. So we'll get integral. So x varies from 2 to infinity. So u will vary from log 2 to log infinity will be infinity. So that will be log 2 to infinity. 1 by x dx will be du. So we'll get du by u square. Integral of 1 by u square is minus 1 by u from log 2 to infinity. So we'll get minus of, at 1 by infinity is 0, minus 1 by log 2. So the value is finite. So therefore the series will converge by integral